Welcome to my projectbazaar.com. Our product title is a normal I/O order Radix-2 FFT architecture to process twin data streams for MIMO. The abstract. In our product, we have proposed an multiple FFT processor that can handle independent multiple data streams with less number of registers and that provide high throughput. These fast Fourier transform operations are carried out by FFT processor that can handle simultaneous computation of multiple independent data streams and provide the output in terms of their natural orders. In our product, we have designed an multipath delay commutator in the FFT processor for the MIMO transmission model. The odd and even samples of the twin data streams are processed in terms of their time and frequency decimation in the FFT processor. The proposed architecture is designed to process two independent data streams simultaneously with less number of hardwares. The odd inputs, which are in natural order, are first bit reversed and are then sent to the FFT processors, and then the even samples are next bit reversed and they are sent to the DFT processor. The process of odd samples and even samples decimation are carried out in terms of their clock cycles. The modular flow diagram. In our proposed architecture, we have used a single FFT processor that can handle multiple input data. Primarily, the input data streams are converted into twin data streams. The data from the twin data streams are then processed to the register delay commutator. In the register delay commutator, the binary bits value are stored in the registers, and then it is processed to the decimation in time multi-delay commutator FFT processor. In the FFT processor, the FFT processings are being performed. Then the bit reversing unit. In the bit reversing unit, the register delay commutator register values are being bit reversed in the bit reversing or register array indexing delay commutator. Then the processed value is finally sent to the butterfly unit. In the butterfly unit, the data are being arranged to their natural orders and they are sent as the processed output. Initially, the 16-bit binary input data is taken as the twin data stream and they are processed in the FFT architecture of 6 levels. The odd and even samples of the binary input data streams are separated by means of using switches, the switch 1 and switch 2. These switches SW1 and SW2 act as the swap switch according to the input clock cycle. The register content values are added to the register delay commutator with the n by 2 number of clock cycles. The odd samples and the even samples are added to the register delay commutator according to the number of clock cycles that is given to the input as the FFT architecture. Next is the Radix-2 FFT 8-point DFT processor. In the Radix-2 FFT architecture, the register value contents are being swapped for the first set of clock cycles of the odd data and swapped for the next set of odd cycles for the even data. The data is being fast Fourier transformized and they are sent to the butterfly unit. Initially, the values are being bit reversed and they are stored in the register delay commutator. In the butterfly unit, the bit reversed values are again bit reversed and they are produced as the natural output data. This natural output data is the required processed twin data stream. Hence, in our product, we have used less number of registers and we have acquired high number of throughput. Open the VLSI software and run the program. Provide the value for the clock input data. the value for the preset data, provide the value to clear the registers, provide the value for the twin data binary input stream. For the first set of clock cycles, we are able to find the output of the subprograms of our module. For the next set of clock cycles, we are able to obtain our required process FFT output. To view the RTL schematic diagram, go to implementation and click view RTL schematic. Add the main program and click create schematic. The schematic diagram of our product is being obtained. This is the required schematic. For viewing the technological schematic, add the main component program to create schematic. The required technological schematic of a product is being obtained. Next we have to get the value for the design summary report. In the design summary report, click the synthesis report. From the synthesis report, click the device utilization summary. From the utilization summary, we can able to obtain the number of LUT flip-flop used and the number of LUT flip-flop unused and the value of I bonded flip-flops that are being used. From the timing summary, we are able to get the compilation time of our product. From the device utilization summary, we are able to get the value of number of LUT use, number of flip-flop use and the bond and RAM register values. Click OK. From the compilation, we are going to obtain the total on-chip power 1.738 milliwatt, which is very low, and we are able to obtain the high conditional throughput